We're going to apply the variation of parameters formula to find the particular solution to this differential equation here with our homogeneous solutions given to us. So first thing to do is we actually don't have it in the correct form, right? We need a just y double prime by itself. I can't have that x squared there. So first I'm going to divide everything by x squared. So y double prime times x squared divided by x squared, that gets rid of the x squared. So I have y double prime. Then I have minus 2x over x squared, and then times y prime, and then plus 2 over x squared times y equals square root of x over x squared, which I can rewrite that x to the 1/2 and over x squared, that ends up being just 1 over x to the 3/2. All right. I don't care about simplifying these too much because these functions, the p of x and q of x, don't appear in the variation of parameters formula, so I just need my g of x in the correct format. So there, right there is my g of x. All right, next thing is we have the Wronskian appearing in both, so I want to just compute that before we start going here. So the Wronskian of y1 and y2, so I have x and x squared, equals determinant, well, here, let's just do it, sure. Determinant of x squared, and I take the derivatives, so that ends up being a 1, that's a 2x. Okay, and that's equal to x times 2x, so that's 2x squared, minus x squared times 1, so minus x squared. So it's just x squared is the Wronskian of y1 and y2. All right, so now let's go ahead and just plug stuff in. All right, so here, and I got to keep in mind, I got to make sure my y1 stays x and my y2 stays x squared. It's got negative y1, so that's negative x times the indefinite integral of y2, so y2, that was x squared, times g of x. Well, g of x is, I'll write as 1 over x to the 3/2, and then times 1 over the Wronskian, so times 1 over x squared. All right, dx. Then I've got a plus y2, well, that's x squared. And I've got indefinite integral. I have y1 times g of x, so y1, that was x. G of x, again, that's 1 over x to the 3/2. And then times 1 over the Wronskian x squared, so 1 over the Wronskian, 1 over x squared, dx. All right, let's go ahead and simplify that. So we have negative x, indefinite integral. You have x squared and x squared, those cancel, so I just end up with 1 over x to the 3/2 dx. You have plus x squared, integral, okay, x squared, okay, so I end up with 1x canceling, so I have 1 over x left over, 1 over x times 1 over x to the 3/2, that ends up being 1 over x to the 5/2 dx. Right, and it's going to be a little simpler to change those to be on the top with a negative exponent. So I'm going to write this as negative x, indefinite integral, x to the negative 3/2 dx, plus x squared, indefinite integral, x to the negative 5/2 dx. All right, so the integral here, let's see, we have negative x, indefinite integral of x to the negative 3/2. Well, kind of going backwards, right? To get to negative 3/2, it's a power rule, so we're going to add 1, so we get negative 1/2. But then I don't have any numbers in front of here, so I should have a negative 2 in front, end up canceling out the negative 1/2 when the derivative is taken. If I want to be careful, there is a plus c1. And I've got plus x squared. And the other one, I have x to the negative 5/2, so if I go backwards and add for the power rule, it's going to be x to the negative 3/2. In this one, I need the reciprocal, so that's going to be negative 2/3, because there's just a 1 in front. Sorry, I forgot my plus c2. And if we multiply that out, so we end up with, let's see, negative x times negative 2 times x to the negative 1/2. All right, so that's going to be positive. And we have, okay, a 2 and a positive x to the 1/2. All right, and then plus c1 times x. Sorry, minus c1 times x. And then I've got a plus, okay, I have x squared times negative 2/3 x to the negative 3/2. Okay, so x squared times x to the negative 3 halves, that ends up being x to the positive 1 half. So I actually need to get rid of my plus again, sorry. Let's say minus 2/3 x to the 1 half, and then I have a plus c2 x squared. Let's try and finish this off. All right, so let's see, I have 2 square root of x minus 2/3 square root of x. So let's see, that ends up being, that's the same thing as 6/3 minus 2/3, that gets me 4/3 square root of x. And then left over, I have a minus c1x. And I have a plus c2x squared. But if we look at the last two, we actually just get the entire solution at once, plus the homogeneous, right? So the 4/3 square root of x, that's the particular solution, but we also got a minus c1 y1, then a plus c2 y2. And so really, if we just want to look at the particular, we can ignore those, and y particular, the new thing that came out, is this 4/3 square root of x. And if we were to write out the entire solution, right, we'd have the entire solution be the particular plus c1 y1 plus c2 y2. So these just kind of pop out as you're doing the formula if you include constants from the indefinite integrals. But that's our particular solution, 4/3 times the square root of x.